Okay, again, welcome you all. So we are in our fifth lecture, and uh, today we have two tasks in our routine lecture program. One is hypotheticals. I have to discuss something about the hypotheticals, and this tutorial, this task basically linking the hypotheticals with the petroleum assay creation. But we have a separate chapter or a list of modules for only petroleum subject point of view, in which we will discuss the oil characterization. We will discuss in detail how oil is to be characterized in HYSYS and crude oil, and how different crude oil assays can be merged or can be mixed with each other, as discussed by Mr. Parth today. Anyway, so let's start. So hypotheticals means what? When we do any simulation in Aspen, then we are very much limited to our towards our substances. Now, for example, if you are watching in your pure component list, so you have a very hefty components, but definitely these are not all species available in the universe. These are those species which are very much important for several processes. In early days, this list was very limited even, but after the advancement of the versions, the Aspen Tech has incorporated some other components in up till now, and now this list is still huge, but this is not comprising or contains all species. So once if you will not find any sort of material, for example, sometimes if I put, I don't know, but if I put lignin, uh, for example, so lignin is not available in this, which is a prime material of some biomass, and we have to use. So these type of things, if you are not finding the species in this list, then what to do? Should we not use HYSYS? No, it's not the way. You have to create your own components, and this aspect is called the hypotheticals. Now, if you see in the select menu, we have three things available. One is a pure component. By default, pure component is selected, and we can see all pure component list with their all families. We can also what you call restrict the particular species, like, or if we want only hydrocarbons, so you can see only hydrocarbons here. Anyway, so now hypothetical. When you click on hypotheticals, you will find this type of menu. Now, this is a menu where you can estimate or you can create the hypotheticals. Now, by default, when you click on the hypothetical, then the method is create a batch of hypos. By default, this method is clicked, and it will ask you that put some initial point and final point, boiling point, and you are being said that from 30 to 900 degrees centigrade, you generate hypotheticals, and between the 10 degrees centigrade difference in each. So a huge list of hypotheticals could be created automatically. This method is available also in this tutorial. We will discuss this, but usually this method is for creating a bulk of hypos, differentiating their boiling points. For example, if I say I want one group of hypos which has 100 boiling point is starting, and 300 boiling point is starting, and interval is 50. So it will create 100 and 150, then 200 and 250 and 300. So if I say generate hypos, so you will see that these six hypos generated, and their names are created according to their boiling points. So, for example, NBP, normal boiling point, 0, 100. This last number is showing their boiling points. You can change these names, but no need to change the names. At least for this kind of hypos, and you can recognize the species with their number, like 250 is that species or that hypo which is being boiled at 250 degrees Celsius, and their corresponding properties are automatically generated from their internal mechanism. So this is one way. Now you have hypos, you can add all. So these hypos are now in the list, and you can use these hypos or substances in your simulations. The other thing is that other way is that you do not want to create hypos like this, but you want individual species. So you change the method, create and edit hypos, and then you have to create a new hypo. Now you will see only one hypo is generated by default name hypo 200 and 5 and star. Remember one thing that all hypo substances names are recognized or can be symbolized with a star at the end of the name. Even if you don't give the star in the name, you will find the star automatically appears after it is created. Now, hypo, for example, if I say this is my new substances, I can put any name, lignin. So now you have seen that lignin and a star automatically comes after my typing. So you are now you must have their properties uh, um, inform as much information you will provide here, the created material behaves realistic, more realistic. For example, if I say normal boiling point, for example, 120, and I'm just putting random data, liquid density is 365, TCPC. Even you can estimate unknown. So they calculated the remaining things were calculated according to their formulations. And in the on the background of the software, there is a mechanism. If you provide few things, then the estimations automatically perform. But these values are not a real one, definitely. Um, the values comes on some judgment of boiling point and molecular weight or something else. Anyway, you can also use this lignin as well in the list. So in this way, hypos are generated. Now, some extension of after creating the hypothetical components, this particular tutorial is forcing or getting your attention that why we do this hypos, why we do hypos only for the petroleum subject point of view. So I'm following the tutorial, or I'm just giving you very quick demonstration of the tutorial. I'm following the almost similar aspects of the tutorial. I'm creating new case, and I'm generating the hypothetical series. For example, create a batch of ISO from 300 to 900. Okay, 10 degrees centigrade. If you generate hypos, you will see a very huge list will be generated. So I said add all. So now these are my hypothetical components. Basically, these hypothetical components are the components of oil and gas nature, which whose the lowest boiling point is 30 and the highest boiling point is 900. Usually, these are the species which could be found in crude oil, because crude oil it has no any fixed specification that what are the compositions of different hydrocarbons are there. So we usually define the crude oil with these hypos that one species is available which boil at 80 degrees centigrade. One species is available which boil at 90 degrees centigrade. Now, after taking some fluid package, we can go in the simulation, and you will find if you put some stream here. And now, how to give the composition of a particular crude oil? This is very important and very difficult aspect that these all hypos have. What is the mole fraction or mass fraction of these hypos for a particular crude oil? So one way is that you have generated hypos just now, and you go in the petroleum in the in double click, and you
स्क्रीन
go in
वही
the
है पेट्रोलियम में।
petroleum. You go in the assay, petroleum assay, and you have various ways to generate or to link up with some petroleum assay. But here I'm as tutorial following. I am just giving the composition from some already built library. Uh, Before we go further, I want to explain. Uh, I hope you all are experienced persons, but at least I have to discuss this that throughout the world, the crude oil is defined with their assay. Assay is basically a regional composition of crude oil. For example, if in the world, the crude oil geology is divided in several basins or several names. Like, for example, in Asia, this is a champion expert, this is Shengli, this is this. So you will find this data is already generated by several companies, and the data is very much authentic. And now Aspen has summarized or created the database, and you just need to select any particular crude oil. For example, if I say I want to have some region like Australia, and then we have, and from Australia, these are the crude oil databases. So I put I just click any particular crude oil, and I just okay. So you will see that it will import the already composition given by the database, and it will show you the different cut information and true boiling point, and this and that. Their information is there. Now these are the cuts. 20 cuts available. Cut means they have defined this as a in the form of temperature differences at. So 20 cuts means at the 20 temperature intervals, these species come out. Okay, we are not very much interested to see these, but what we are interested that you will see that composition automatically filled according to this crude oil. Now this is a composition whatsoever we have selected from the database of assay. According to that database, each hypo component has given some composition. So you can see that this has this much more fractions is available, and you need to now to completely define of the stream. You need to give some temperature and some pressure, some mass flow rate. So this stream is completely defined. Now this stream is actually showing the crude oil which we have selected in this petroleum assay. So this is a Jackson blended 1983. This is a particular type of crude oil composition and assay. We have assay, we attach assay from this library and to this stream, and this composition is showing the same assay which we have selected. So I hope you got the idea, but this lecture is not for the oil characterization. See, in when we go in the properties, we have discussed these two aspects of these properties. One is component list. We have now we can create components and we can insert the components. Today we also learned how we generate the hypos. Even we have third thing is a hypothetical solid. We can generate the solids from this new solid, and we can add the solid and its density. So this is how we can add solid as well from hypothetical components. So we have discussed components yet, and we have discussed the fluid packages. Now we haven't discussed the petroleum assay, reactions, and other things. So petroleum assay lecture will be in our future tasks. So how petroleum assay generated. This particular aspect is called oil characterization. I will explain how oil is to be characterized in the HESPIN and how it is being utilized. In that particular demonstrations, we will discuss how more than two assays, two or more than two assays could be mixed together, and we can have a mixture flavor of this. And we can also estimate different properties which are very much important for the oil and gas sector, particularly oil sector. Hopefully, you have seen this, and if you have any question, let me check. Is there anyone who wants to join? Because I haven't seen. Ji Kashif.
And no, but you added these hypothetical components. How do they get like the other properties and um you know what they create by themselves, and how is that possible? Did you put the boiling point by yourself, for example, or
Uh,
HYSYS just estimates it by itself?
if you're talking about the hypos which are generated on the basis of, let me go there. If you are talking about the hypotheticals which we have just generated, these we have methods. I am showing you methods. Now, this is a one method. Create a batch of hypos. Yes, hypos. When we define these two temperatures and intervals, the hypos generated and their respective properties automatically. For example, if I have remove all, so uh, it will say error because okay. Now this particular hypo which we have generated. Now, see, italics is fonts are there, and densities and molecular weights and TC, PC automatically estimated by the HYSYS software. Within this range, if we generate the hypos, then their corresponding boiling on the basis of their boiling point, molecular weight and other things are automatically calculated from some formulations, built-in formulations. But if you will go to create the hypo of your own, for example, if I say new hypo, then you need to provide some data, at least its boiling point, and then can you can click estimate. But when you are in real simulations, for example, if you are going to simulate a process for industry, and you found some material like lignin, and you want to create that the hypothetical for lignin, then you do not uh, rely on the estimation of the HYSYS software, because HYSYS software could rely on some wrong formulations. So you need to check their all properties from the other data banks, from books, from internet, from some websites, and then you exactly put by yourself. Otherwise, if you rely, okay, these are good enough for the crude oils. Ye- These components which we have generated by batch processes, because this HYSYS is specifically uh, created software for oil and gas sector initially in 1960s, and still this software is highly used by oil and gas sector. So it estimates very good estimations or values of boiling point, molecular weight, and other things when we generate the hypos with this formulation, and they are very much relied by the oil and gas sector. But for a special species which we want to create, we cannot rely. But if we do not have the data, like we do not have the critical property data, then okay, we could rely, and then we validate the software, we validate the simulations, we validate the case. If we did not get the results, so then we can change their values later on.
I'm particularly concerned about this molecular weight, especially in the batch of these hypos that you're creating now. So, can we just change the molecular weight of, for example,
Yeah,
3 or 4 components and
yes.
leave
You
the
can you
rest
can
of
you can
them?
you can change. For example, if I created this list and I haven't I removed this and now I am this, I can change the molecular weight. For example, it is 81.93. I can change 90. Now it is totally dependent on me. Now you can find two type of text. One is a blue bold text, and one is other one is italic, blue but italic. Oh, my access is just gone crashed. Blue bold text basically giving you uh, the data which you actually specifically inserted. And the below italic without bold data is actually the estimated values by ISIS, but they can be changed. Black text cannot be changed. In after simulations, you see that when you click on the run or automatically when automatically some calculations performed, then black text uh, is uh, is for the dependent variable. So just I want to show you my software was crashed. Okay, when I go to new, okay, and add, and now I am generating some hypotheticals, and in the group, I restrict my group with for 100 and 300 range, and interval is of 50, just to make 6 components only. Generate hypos, so you will see this. So you can change the molecular weight. Now once you change this, now see, once you change this, the other properties automatically goes to empty, 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 because now you can again estimate, click on the estimate button to re-estimate on the basis of new molecular weight. So they could again estimate. Even if you change the density, then you will again click on the estimate. You can change, but once you change this, remember, once you change this, now this is your independent variable. Rest of the things are not independent variable. Only your boiling point are independent. Their names and this particular particular value is independent. Now you can add all. So uh, even you can check what is the molecular weight of particular thing which you change. So I think that was this one. So this is क्या change किया था normal molecular, okay, molecular 133. Yes. See, any other molecular weight is not shown with the bold blue. But the component for which you change the molecular weight, that was the second one. And now 133 molecular weight is showing us a bold blue color. So anyway, you can change and you can re-estimate.
Okay.
See, okay. Should we move on?
Yes, yes, please. Yeah.
Okay. Now our second today's talk will be on our new thing, which is not new for the chemical engineers, but new for our HYSYS learners in our course. That is nothing but the heat exchangers. So for this, for demonstration and understanding, getting understanding of the heat exchanger, we must have some component. So for the sake of simplicity, I demonstrate whole things by keeping our species only water and our usual fluid package, which is Peng Robinson. Uh, Peng. Robinson. Okay. Okay. Now, this is the heat exchanger. We have, if we see heat transfer equipment, we have a regular heat exchanger, which is a shell and tube heat exchanger, and we have also plate and frame heat exchanger as well. This is a new addition after version 10. ये वर्जन 10 में नहीं था, अब 11 में के ऑनवर्ड आया है. Anyway, कुछ और heat transfer devices भी हैं, like this is a fired heater, this is a air cooler, and this is a LNG exchanger. LNG exchanger mostly used in the oil and gas sector or gas industries. But here I will demonstrate particularly this heat exchanger as a simple case, and then we will see later on what other things are there. So for demonstrating heat exchanger is a device which actually exchange the heat only without any mixing of the species itself. So we need two stream at least. One is for hot fluid and other is for cold fluid. So this is one stream which I say this is a hot water in, and its temperature is 80, and its pressure is let's say 2 bar. It's some flow rate is there, and its composition is 100% water. Okay, so stream will be converged. This is our one fully converged, fully defined stream. Another stream is cold water, and so we have 25 degrees centigrade. We have again some pressure. We have again mass flow rate. These two streams are uh, this particular demonstration. I am completely defining these two streams. So two streams are completely. Now I put this heat exchanger in the icon of model palette. You will find that the shape is different. But here, when you drag and drop, the shape will become different. But you can change the shape. For some equipment, you can have a different change icon. So you can have these icons. कुछ लोग इसको पसंद करते हैं, कुछ लोग इसको भी पसंद करते हैं. It doesn't matter. So now, if you double click this heat exchanger, so in the design and connection page, design tab and connection page, you will find four streams entry requirement. Definitely, this is a shell and tube heat exchanger. So we have one fluid which is going to the tube side and coming out from the tube side, and another fluid which must be inserted in the shell side and also coming from the shell side. Okay. So I have defined hot water as per general understanding. We have no any particular rule, but it is a thumb rule or it is a heuristics of process industry that we must have a hot thing in a tube side, because hot or high temperature thing deteriorates metal. So it's better to have only problem with the only one metal of the tube, and the tube can be replaced. But if we put hot side in a shell, then it will also erode or corrode to the tube upper surface and also the shell inside surface. This is a one general heuristics, but we हमने भी अभी इसको वही उसी तरीके से किया है. Anyway, so we have hot water in and cold water in from tube side and shell side respectively. Now uh, we generate streams of outlets from both the outlet boxes. Hot water out, hot water out, and cold water out. Um, these are just names to recognize that this is a hot water and this is a cold water. Otherwise, sometimes students usually say to me that, sir, when cold water in, it will get heat and it is now hot. So it doesn't matter, but I'm just recognize the things that this is cold water in and out, and this is hot water in and out. Once I inserted this information, then I need to go in the parameter because for this time we have enough information. We have provided enough information, and then go to the second page, the design tab. Now parameter. Now here heat exchanger model, which particular type of formulations or equations you want to use. We have several ways. Simple endpoint is by default click, but we have also rigorous heat exchanger modeling, simplicity rating, simple weighted, and dynamic rating. Basically, simple and simple weighted. These two are very much easy. Or by we have just to see that how much outlet temperatures of some sort of species or streams. Actual heat exchanger modeling is rigorous shell and tube heat exchanger modeling, but this cannot be activated at first. First, we have to convert the heat exchanger in simple endpoint or simple weighted, and then later on we can activate rigorous modeling by some method. Okay, so I'm saying simple weighted. Simple weighted means some sort of information is provided, and then we have to understand what are the upcoming things. Okay, uh, चाहे तो आप simple end पर रखें, doesn't matter. You can you these two almost all same thing, simple endpoint and simple weighted. Okay, heat leaks by default we have given none, but you can have these two other options as well, extremes and proportionals. If you have a heat leaks, you want to calculate the losses. So we have only two formulas, extreme and proportional. We cannot set some sort of variables in this. When we click extremes, and then some formulations of Spintech are already inserted in this on the back end. What mean by extreme and what mean by proportional. But by default, none is there. Means no any heat loss. Pressure loss from the tube side, definitely fluid is going through. So now, if we put 0 and 0 here, case will be solved for this for simple endpoint, no issue. But later on, when we have a rigorous modeling, then this 0 0 will not work. So instead of 0 0, I put some pressure drop in the bar, 0.02 bar, 0.02 bar. Okay, so okay, now this is our geometry information little bit, like how much tube passes are there. By default it is saying 2. You can change here. Shell passes, by default it is a 1. You can put some values here. By default values means you are agreed with the 1. Shell in series 1, and passes counter or co-current means parallel or counter. Shell type E and F, the end cups of the uh, shell. Anyway, so when you have this thing, then you can go in the worksheet. Now, because this is not solved, because it says the under specified. What we mean by under specified? Under specified means now we need one more information to have a convergence. For example, this is a hot water in and cold water in completely defined by us, but the outlet streams, some values are automatically calculated. For example, what mass flow is inserted from hot water in, the same mass flow will come out. So the HYSYS automatically calculated this. But the thing is, which is not still not yet decided by the HYSYS, is the temperatures and the vapor phase fractions of the streams at outlet. So for both the streams. So for example, this 80 degrees centigrade, if I say this 80 is dropped down till 60, so you will see that it will completely converge. on the back end. You can see now the color of all things become perfectly uh, uh, blue, dark blue, and there is no any outline, yellow or red outline to the heat exchanger. This shape is called completely converged heat exchanger. Uh, no any problem. Even sometime convergence is there, but the heat exchanger outline is become yellow or sometime red as well. So we have some issues in that particular moment, but here it is said okay. So hot water, when we say this hot water is decrease its temperature from 80 to 60, then cold water has increased from 25 to 30. For example, this is not our case. We are given, we know that the cold water is raising the temperature from 25 to 35. So we have deleted the hot water outlet temperature and we have to provide this. So in this way, you can change in the rating. You just define the geometries and information by default. Some information is there, but rest of the things you have to be inserted here. But one thing is there that geometry information is not workable in under this method, simple endpoint or weighted, because geometry information will work only when you have a rigorous mode. Okay, shell side and tube side. These things have nothing to do with the calculations. Only calculations are only performed on the basis of the simple heat exchanger rating. In a heat exchanger, we know that whatsoever amount of hot water or hot fluid is leaving, the cold substance is getting that Q. So, and we can estimate easily by simple calculation. If I say this hot water is cold water is raising the temperature from 25 to 35. Now we know the C of this cold water. We know the mass flow rate. So we from Q is equal to Cm delta T, we can calculate how much energy gained by this water. So we can calculate how much energy lost by this hot water, which has actually gained and without heat losses. So we can calculate simply we can calculate the temperatures. One thing. Now, if I say this 25 degree centigrade will be increased not by 35, but I say 60. So you will see that instead of green bar in the bottom, you will see that uh, some calculations performed, but we are giving message temperature cross. What it means? It means that this is not possible in a heat exchanger world, but at least the calculations performed and it has calculated, but it says that temperature cross is there. So if I generate some some sort of graph for you. I hope you have seen this graph when you were in academics, or if you are still interested in the things in the study, then you can see this in books as well. Yes. Now on x-axis on x-axis, this is the length of the tube geometry, and on the y-axis the temperature. And for the time being, for the sake of understanding, I am saying this is a parallel flow arrangement. Both the fluids are inserted at from one point from left side, for example, and fluids are moving towards the right side of the heat exchanger, and they passes their energy. Heat loss is being seen in the hot fluid, and heat gain is seen in the cold fluid. So this is a temperature profile. Y-axis is showing temperature. Now temperature is going decreasing for the hot fluid, and this cold fluid temperature is going increase. And at the end of the this is the end of the heat exchanger. This is the end of the heat exchanger, where we can see there is still delta T. And this is the inlet for Hari. I have just developed. Okay, so okay, so this is a scenario. This is a left side is inlet and this is outlet. So this is your on the left side. This is your delta T at inlet. For example, this is 80 degrees centigrade. This is 25 degrees centigrade. So you may find some difference in the outlet streams, which is called the approach of the heat exchanger. This is a normal thing. Now, is there any possibility? What do you think? Anyone want to guess? Is there any possibility that this exchanger crosses this exchanger give us these kind of results? Yes, anyone? Sorry.
No, you can't have this much. You can't cross the temperature.
Why?
You can be ideally you can just get the equal temperature of that thing.
Yes,
Uh,
ideally, you have a zero difference. This blue line touches the red line at the end. This is the most ideal situation and yeah, or last possible point. But even this is also ideal. But this is not possible. That heat is being gained even in a negative form. Means यहाँ तक जो है वो ये जो क्रॉस कर रहा है रेड और लाइन इधर तक तो ठीक था फिर भी लेकिन what is happening, this is not realistic. This cannot be explained by the thermodynamics. So but you can perform the calculations, you can get the results in a negative form of some streams, but this is not possible in a realistic world. So HYSYS actually calculates the values, but gives us the error. Temperature cross is there, and even if you see on the back end, if you see that yellow line is now coming on the outlines, the outline of the heat exchanger, it says that somehow it has calculated the values, but the values are not realistic. So this thing is not good. Okay. So now we are back to the 35. Now, if you go to the performance tab, then you can see very important informations like duty, like heat leaks. Even we have a zero, like overall heat transfer coefficient, minimum approach, LMTD log mean temperature difference, and some other things. You can also build the plot with the variables. For example, if I say that heat flow, okay, on the x-axis is the temperature and on the y-axis is the heat flow. Tube side is green. Tube side, when temperature is there, this much heat is being flowed from this thing. Anyway, you can see the tabular data as well. Okay, now if we click on the rigorous tab, at the moment you are not find anything on this particular aspect. Okay, now go in the design. Now, for example, you go in specifications. These are default specifications that we have to provide this temperature outlet and it calculates the things. But what happened if I add some other specifications for the calculation? For example, if I want to say that delta temperature, this is the by default specification. For example, if I say no, I want to put LMTT and I want to put LMTT on overall. And for example, if I say this is the uh, 31 degrees centigrade is LMTT. Now it says over specified. Who can explain why it says over specified? Under specified means we have less information. We have to put some information. Over specified means more information is being given. So this temperature now should not be given. and it is automatically calculated by the software. Though the software is calculated almost similar kind of value, because I have already seen that LMTT was calculated in the range of 30 and somewhere. You can change the LMTT. Now you can change the LMTT. For example, this LMTT is 20. You can have some sort of differences. You can have now this is 30 degree instead of 25 to 35. It is now 38. So now you you control the things or calculations on the basis of LMTT specifically. But if you this is a by default active. If you unactive, so again under a specified, now you need to define again temperature, because now this is now as a sorry, this is now a similar case which we have done before. Okay, after this, after understanding of this primary convergence of the heat exchanger, what we have to do now, we have to convert this in a rigorous modeling. Now, rigorous modeling approach can be achieved via several ways. One is this in the bottom of this parameter, you will find two buttons, convert to rigorous model, and you have two ways to go. One is a size exchanger and is a specify geometry. It's better to go with the size exchanger. When you click on the size exchanger, it will ask auto size, auto sizing template, size interactively. This is a good way to give the data with the size interactively, means you want to give the data by yourself. So you say convert. Now you will see another graphic user interface. This actually graphic user interface is coming from entirely other software, which is Aspen based software, Aspen EDR, Exchanger Design and Rating, Sizing. I will also demonstrate the EDR someday, that what are the features of the EDR specifically, but we are here because we have asked or requested HYSYS to do this for us. So now we are in EDR. EDR basically ask us from for some specific things, and then if we are agreed with with the information, and then modeling will be done by the EDR as well. For example, we have to, there are few types, geometry, process, error, warning runs. In the we are by default on the geometry type, and there is a tema type, BEM tema type. Which type of B means bonnet? What how the ends of the heat exchanger are look like? These are the some standard endpoints you may find in the industries. How these ends or end cups of the heat exchanger are designed. P means the bonnet bolt or integrate with this chute. So E, how the central piece of the exchanger, and M, how the other side of the. So M is the bonnet. So BEM, you can change any of configuration. The things will be defined by HYSYS accordingly. Okay. Then we have now we have to provide particular type of dimension. If you have dimensions, you can define the dimensions. This is a tube pattern. For example, we can select any pattern. By default, it was 30 triangular, and tube passes. Okay, baffle type. I said double baffle type, segmental, vertical, or horizontal. I said vertical baffles. Even you define the default exchanger material. The here is a carbon steel, but if you have another uh, uh, from the list, you can select and specify some size for the design. For here, we have said no. If you have no, then nothing, no information is being asked. But if you have say yes, then it will ask further information. Okay, here it is this thing, and in process you have also several things. For example, you must have one hot side or cold side temperature. Here, hot side temperature is inlet temperature is 80, and outlet temperature is unknown. And cold side, we have a 25, and hot we are getting out 35. You must have at least one temperature provided. Do not give both temperature outlet temperatures, means एक temperature को आपने खाली रखना है. Anyway, allowable pressure drop, we have given this, and fouling by default 0, but if you want to put some value, for example, 0.002 fouling is the heat losses due to the uh, uh, pitting corrosion or corrosions, foul. Okay, so errors and results, this is done. I say size for me, the HYSYS will give us a sizing. It will generate some geometries and even profiles. If you are happy with this, then you can say accept. It says that you have given the data, but now can I change the data? I said yes. So now you will see that OK button. What's the data? Actually, because we needed the temperature of any one stream, so we give a 35 degree. But after the appropriate geometry calculations, HYSYS calculate no, your heat exchanger will have these outlet temperatures. And now this is a performance, actual performance, and this is the dynamics. We will come later on this. Now you have a rigorous tube modeling, and you can change even you can change now and see the impacts. For example, you can see the exchanger things which you have provided, and in the process you have a geometry. You have geometry for both tube layout geometry and the profiles. So this is a double tube, so 2 times profile drop. Okay, so even in EDR, extended design rating, you will have very impressive drawing sheets for this, and you can print and give the fabricator to have the fabrication. There are companies which only earn the money on EDR. Some processes have been designed by other companies, and they gave the design processes to them, and on the basis of that particular designs, they perform the analysis and give the client company to their drawings of EDR. I hope you got the idea. If you have any question, then you can ask, or I suggest you all, which are with me, to have at least this demonstration on your laptops now. And if you have find some difficulties, we can sort out. Yes, Mr. Kashif.
Look, HYSYS has some non-realistic calculations, as you just said. So, why is that? So, if the calculation is not realistic, why would have HYSYS do that? Because then, of course, not everybody can cope with it.
Means HYSYS is realistic. HYSYS has realistic calculations. If you now this depends on how you provide the data, or what type of data you are actually providing to the HYSYS. If you will provide the realistic data, then HYSYS calculate accordingly, and the realistic output will be there. That's why in modeling and simulation, we have very people think that the modeling phase is very difficult, but no, this is not like this. The validation phase is much difficult because once you develop the model, then you have to validate the model that whether it is giving us the right answers or not. And this could be done by real experimental work and real comparison of your modeling results and your experiment. Once after several attempts, if the model is giving the okay result, then we say that okay, now model is validated, and now you can ask any question from the model, and it will give the true answer. This is the same like Chat GPT or AI. Couple of years ago, this AI was not giving us very much correct answers, but now AI is giving us very much robust and real answers. This is how they trained we people are training the AI. So the same situation is this: if you will provide HYSYS the correct information, all the things are in a correct way, the HYSYS will calculate and estimate the things correctly.
No, but the more realistic way could be that the HYSYS could just say, no, you can't have realistic answer. That's not realistic. Wouldn't it be better than having non-realistic answer?
I couldn't get your question, but what I got is see, in our students usually ask me that if we have to provide this much information to the HYSYS, then what what is the use of HYSYS? मैंने हम इतनी इंफॉर्मेशन इसको देने देंगे, हम अगर इतने अच्छे पढ़े लिखे होते तो फिर जो है ना वो हम फिर हम खुद ही कर लेते, फिर HYSYS का क्या फायदा? If your direction is like this, then the answer is that no, still lots of capabilities of ISIS are vulnerable, and you can take the benefit of this ISIS. These are the simple calculations. Think about a giant industry is developed here, and now and that is representing a true industry, and calculations are very much accurate. Validated answers are with us, so we can check cause and effect. Is we can develop the cause and study in cause and effect study. We can change their inputs and get the results.
Okay, I will
Anyway,
discuss this later, I believe.
okay. I think at least you must have this demonstration. Repeat रिपीटेड आप इसको अभी एक दफा करके देखें, मेरे पास ये एक मैसेज आ रहा है। ओके, आप इसको एक दफा करके देखें, अगर कोई इशू आ रहा है, अगर आप मिसाल तौर आपने पहले ये किया हुआ हीट एक्सचेंजर और ये सारी डेमोंस्ट्रेशन आपको ओके लग रही हैं, तो वी कैन क्लोज द क्लास हियर एंड यू कैन ट्राई एट योर लेवल, और आप अपने फ्री टाइम में देखेंगे, या तो अभी आपको ट्राई करना है क्योंकि हमारे पास अभी भी 15-20 मिनट हैं।
Okay, couple of more questions, sir.
सॉरी।
Couple of more questions.
ओके।
Um, oh, why just we can't put heater in place of heat exchanger, or why can't we just eliminate heater because that's another form of heat exchanger?
No, in a heater, if I place both the things, now see, heater has only one stream in and one stream out, and you this heater actually calculates the heat required to raise the temperature, and even the cooler is working like same. But in industries, usually we save our energies by exchanges the heats with the streams which are running in the industry. For example, few hot streams are there, and those need to be cooled down to dispose of, or this temperature is not favorite in the upcoming operations, and this stream has to raise the temperature. So we exchanges heats to save the economy of the process. So heat exchanges are better for reducing our energy consumptions. I think uh, there is a subject in our chemical engineering nowadays which is called chemical process design and simulation. In this subject, we have one complete lecture on HAN, heat exchanger networks. Have you gone through all of you, which are available in my online class? Have you seen or have you heard about the HEN, heat
No, no.
heat exchanger? I want to show you one my lecture, and very interested and impressive lecture. Just few slides of that. Hopefully not boring. PE subjects and फहद, आपने देखा है ये, कभी सुना है? सोया
नहीं
हुआ है
सर,
क्या?
नहीं सर।
You know, we never had that kind of simulation at our university days because the simulators were not that much intelligent by then. In fact,
हाँ,
the simulation just started by Hyprotech.
No,
Those
this is
old days.
okay. I just I want to show you why heat exchangers are important to us. Now, this is my lecture, routine lecture, and in that subject, chemical process design and simulation. So, HAN is just to optimize the energy consumption in industries. So these are the basic informations to the students that what are the heat exchangers. Heat exchangers have transformation of energies from hot to cold fluids. Okay, after I'm just skipping these things. I hope you are good enough in this. Okay. ये तो हैन का पहला पार्ट था, ये तो बेसिक था। मैं आपको असल लेक्चर की तरफ लेकर जाऊं। Okay. Now there's a problem. Design a heat exchange network that has four processes streams with inlet temperature of this, and respective outlet temperature. So the four streams are there in the industry. One is at 30 degrees centigrade, and it has to be raised up to the 135 degrees centigrade. And 80, the temperature of 80 stream is to be raised to 140, and two cold streams are there, 150, which is to be cooled down to 30, and 180 to 60. So these are the two hot streams, 150 and 180, and two cold streams, 30 and 80. So, for example, if I need to reduce this temperature for a hot stream, which is 180, and we have to reduce up to 60. So, and if we assume their C's means multiply of mass flow rate with the specific, this is a heat capacity flow rate C directly. So that's 3. So if you take the temperature difference of this and multiply with the 3, you will have 3860 kilowatt. So to cool down this stream, we need 360 kilowatt. Similarly, to cool down this, we have 120 kilowatt. Similarly, if we heat this cold stream from 30 to 135, we have to 210 and 300 for other stream. So total hot load is 480. So we need 480 kilowatt from cooling water from cooling water side. And similarly, we have to raise the temperature of these two streams. So cold load is 510. So if we add both, then we have almost 990 kilowatt requirement in this stream. So if you install two heaters and two coolers, so total energy required will be 990. But when you have, but you need to insert heat exchangers to transfer the heat. And this problem basically demonstrate that how much heat exchangers you will install. So this is a detailed demonstration. I will show you the last picture because it needs at least 3 hours to explain this. Now I'm showing you the last. Okay, this is the last lecture that how you arrange the heat exchangers. See, this hot stream is going. You insert 270 kilowatt heat exchanger, which exchanges the energy of cold stream 2, which is to be raised from 80 to 140. But this will not give us a proper our total energy requirement. So it will only increase 80 to 134. So now we want a 140. So here you need a heater from 134 to 140. Similarly, now in this diagram, you are watching that we have inserted four heat exchangers. Yellow are the heat exchangers. One is this one is this one is this one, and one is this. Four heat exchangers and one cooler and two heater. Now heater 50 and 30, total 80. So now total heating load is 80 kilowatt. In the first slide, I showed you that this was 420 kilowatt. So we have reduced the total requirement of utilities to 80 kilowatt only, and internal exchanges are being done in the industry. Similarly, total cooling load is 50, which was initially 510 kilowatt. Rest of the work was done by the internal exchange of the. So this is why we insert the heat exchangers, and the heat exchanger network is a big subject, and here is a software which is called energy analyzer. If you, because you have installed um, Aspen Engineering one suite completely. So hopefully you are watching Aspen Energy Analyzer. This software actually calculate the hands, heat exchanger and networks diagrams, more economic understanding, or more economic uh, uh, feasibilities of the development of the heat exchanger network.
So that means those heat exchangers are economical to get this temperature to a particular limit, and then you have to use heaters or coolers, right?
If you are still required uh, further requirement of the increasing or decreasing temperature, then you need. For example, in this diagram, if you are watching, hot stream one is fulfilling its requirement, which is actually requirement is to convert 180 to 60 degrees centigrade. So the requirement of this stream is fulfilled by the heat exchangers only. No need of any cooler. But hot stream 2 has two exchangers, and then remaining requirement will be done or will be taken by cooler. So similarly, with these two streams as well for the cold stream. So heat exchanger usually available in the industries uh, in a very huge quantity. And recently we got one project, rather than one, we got three project. Day before yesterday, we got one meeting with the Rafan Maze, and we got two project on the heat exchangers, designing and optimize the heat exchangers quantity and quality. Means, and they have no any idea about the hen, but I said that you are asking about the designing of the heat exchanger. So this work is done in all industries. Okay,
Okay.
so
And
see,
you do this by economizer, or what program you use EDR?
first we develop the model and we use simple heat exchangers. Then if I open any EDR, so you will be very much get some interest in EDR, Aspen EDR exchanger, Aspen exchanger design and rating. In this exchanger design and rating, it will ask you that do you have any solved case of HYSYS which has installed heat exchangers? So if you have such case in which these simple heat exchangers are installed, so you can import in the exchanger you can import like this. Like if I say new, I said I have to design the share and heat exchangers. तो ये हमसे पूछता है कि आप ये तो उसने मुझसे पूछा कि हम क्या करेंगे, हमने कहा न्यू करेंगे. We can import the case from any developed case from HYSYS. ठीक है ना. और आपसे ये केस फाइल मांगेगा. अगर आपके पास केस फाइल अवेलेबल है कोई भी, तो उस केस फाइल से आप लाइक ये उसमें से उठा लेगा कि कितने हीट एक्सचेंजर्स हैं. So I think this subject is getting huge, and we will have in the very last we will have again come back to the EDR, and we will see what EDR can do. And the EDR has very robust capabilities to design and to generate professional drawings and some other data and even costing. कि कितने हीट एक्सचेंजर की कितनी कॉस्ट लगेगी, मटेरियल की क्या होगी, लेबर की क्या होगी, ऑपरेटिंग क्या होगी। ये बड़ा एक जबरदस्त सॉफ्टवेयर है। आपको इस सॉफ्टवेयर को बाद में यूज कर सकते हैं once you have a converged heat exchanger in your process.
Okay, about the pair components.
Sorry?
About the pair components, for with this HYSYS, if I, for example, I'm looking for ethylene. I search ethylene in the simulation names, and there are 3 or 4 ethylenes there. So how do I know which one to select?
No, if in a name you can recognize by their formula. Sometimes formula is not appropriate. What I mean to say, for example, I have said methanol. Methanol formula we usually know CH3OH, but in this formula write up of HYSYS, they merge all C's and all H and all O. So you have to see, okay, what are the things. Now,
Can you
if I
please
say
type ethylene?
ethylene,
ATHYLENE. Yes, see all
ethylene,
of these ethylenes. Yeah, see.
ethylene. This is ethyl. This is ethylene and ethane. I think in no any differences in their properties. If
Formula
you
is the
if
same as well. I
okay,
mean,
if see now ethylene and ethylene amine. Sorry, amine कहाँ से आ गया?
no, I mean,
एक इंटरेस्टिंग बात बताएं, बात सुने। व्हाट यू सेड, मैं इसको रिमूव करता हूँ और मैं आपको एक
put
चीज बताता
ethylene.
हूँ। ओके, ATH, ओके,
So there
you
are
have
one, two, three,
three,
four,
okay,
four.
four. You pick any one. For example, I pick any one and I ate.
Mm-hmm. Mm-hmm.
Now you will not see any one of the rest of the three.
Yes,
It means all four are one and the same thing with different names. They created with different names, but all four are showing only one component. Did you got it?
okay.
I'm
So
I'm I'm removing. You will see all four. You can add anyone. Now you will not see any of them. Rest of the things means all four are just different by their names. Now what I'm seeing, what I'm doing, I'm removing ethylene and I'm just C2H4. I'm instead of this, I'm writing C2H4 and I said formula. So C2H4, C2H4, but even you can put only once, so you will not see now any C2H4 component in the list. Instead, this C2H4 is something else, refrain. ये कोई और चीज है
this is
इसका।
refrigerant
हाँ,
1150.
रेफ्रिजरेंट ये कुछ और होगा, इसका मॉलिक्यूलर स्ट्रक्चर कोई और होगा, बट दिस इज नॉट इथलीन। So, four names, five names written by the ISIS means same component.
Okay. One more thing, sir.
Mm.
How do we decide which separator to use? I mean, there are like flash, 3-phase separator, tanks, and component splitters, absorbers,
Uh,
liquid extractors, strippers. So, how do we
now,
decide which one to use?
one thing is that when you go and now if you go in a separator section, these are all separators. Now these first two or three separators are very much simple separators. These separators are basically separate the things on the basis of the vapor phase fractions and the density. uh, this particular first separator or flash separator is separate the streams on the basis of their vapor phase fractions. If any stream contains not 100% 0 or not 100% 1, but instead of this in between values of 0 and 1, then you can use this. If you want to separate these in the different phases of liquid and gas. And if you have to distribute it in liquid and gas and liquids on the basis of two densities, so you have a three-phase separator. But these separators do not have any compositional effects. Compositional effects means if you want to, if your stream contain 50% benzene or 50% toluene, so this flesh and this cannot separate at our required specification. For example, we want a vapor stream containing 98% benzene and a bottom stream contain 97% toluene. So this can be done by the distillation only. Similarly, absorption and liquid restriction has their own meaning, but these first three are the very simple ones. ठीक है ना, ये आपके बिल्कुल सिंपल हैं, बट द रेस्ट ऑफ द सेपरेटर्स हैव सम स्पेशलिटीज। और उनके लिए जब हम ये सेपरेटर वाला का शुरू करेंगे तो उसके लिए पहला एक लेक्चर होगा कि ये जो इसके बाद ये फ्लैश सेपरेटर के बाद जो भी ऑपरेशंस हैं उनकी वजह क्या है देने की, या उन कब कौन सा यूज होता है। द क्वेश्चन इज दैट लाइक व्हेन यू हैव टू यूज डिस्टिलेशन। फॉर एग्जाम्पल एक मोटी मोटी बात होती है कि इफ वी हैव अ high relative volatility, for example, if we have a relative volatility more than 2, then we can use distillation in a good way. But if we have a relativity close to 1, so it means they cannot be distributed or they cannot be separated on the basis of vapor pressure basis or boiling point basis. Distillation is not possible for the isotopes. So we need to think about some other operations. Sometime the relative volatility is greater than 2 or greater than 3 even. But the thing is that it is prohibited to raise the temperature beyond 50 degrees centigrade because the product deteriorates its properties and could be used in the cannot be used in the pharmaceutical products. And our task is to use that product in the pharmaceutical industry. Now, distillation is possible, but the distillation is being conducted at more than 200 degrees centigrade, and we cannot go beyond 50 degrees centigrade. So we use liquid extraction. We first leached out this particular substances in other substances, and then we can separate out the things. So there are so many understanding. This is a giant subject. We have a mass transfer subject. We have a SHMT. We have some basic understanding. So I will give you some very quick glance. I have one presentation which even when I have a table which actually explains at which uh, particular operation is used in which situation.
Great. Thank you for that. Uh, at at some of the basically in every simulation, what is ignored?
In simulations, usually people ignore the realistic approach of inserting the data. People are thinking that the holy solely effort would be would be made on the convergence of the simulation. If we are doing PhD or master's studies, then we want that okay, the model should be converged. But we are not inserting the real data, and sometime we also don't know that what are the equations running behind these mathematical equations or the mathematical understanding or basic phenomena of the substance of the thing. For example, in distillation column, people have no any understanding about the how separation is taking place in the distillation column plate to plate. But when they model and when they are not getting the right answers, so they are wondering, oh, why, what happened? Why this is being done in this way? So I must encourage you all that you must have a good understanding about the chemical engineering as well, because this is a backbone. I'm here only to guide you that which particular thing is where and how it can be converged, where you have to click. Means I'm giving you a click mastery, but chemical engineering is a giant subject.
So that means you can check this box of ignored when, at which conditions.
Sorry,
You have a checkbox of ignored at the simulation stage. Have you observed it? I think.
checkbox. I,
Yes,
I I couldn't understand.
ignored, ignored. Um, I can't. For example, if
Can
you
you?
put some data on, or there is a checkbox down there called ignored, where you have this
Uh,
yellow ribbon, and you know.
you are you this
Yes, yes,
this?
exactly. What's this
Yeah.
for? Yes,
You are asking about this ignorance.
yes, this ignored,
Oh,
not that one.
I got something. Okay, this is not a big deal. Actually, sometime when you are doing bigger simulations, and the convergence of particular operation is disturbing you. So for the time being, you want to move ahead. For the time being, you said, okay, ignore this messaging. If some software, some particular model is not converged, I will see it later on. But I want to move ahead. So this is not a big deal. Even this is not ignored. This is no, not a actual thing with the simulations.
So if you ignore it, that means will still that be counted, or will this just be ignored along with the backend calculations?
It will ignore it ignored actually the messaging here. Now see, if I click ignore, so you are not finding any messages, ignored messages there. But if you
Okay, but
untick,
the unit
if you
operation will be there, right?
unit operation, the calculations perform automatically. You do not want to see any help from this bar.
Ah, okay, right, right. So that was the issue, not the
Uh,
offensive.
Sometime now, sometime what is happening? This is very funny, but sometime what is happening? Sometime when I used to teach in the classrooms and want to be not be what you call um shameful or embracing situation, so I just click ignore कि कोई मैसेज अगर आए भी तो वो कम से कम शो ना हो कि डेटा नहीं है या अननोन डेल्टा पी, तो हम आगे निकलते जाते हैं. This is
Oh,
kind.
okay. It's very useful function then, right?
For us. Anyway,
Like you
I
said.
think you must try this heat exchangers and the hypotheticals lecture. Next time, I will share you some more now separations, and we will move to discuss the distillation, absorption, distillation, and liquid extraction, basic the three operations, and then shortcut distillation as well, very much important, and then their related tasks. Their tasks are bigger, so we could solve only one or two, but the rest of the tasks will be your homeworks. Hopefully, you will enjoy that particular portion of the lectures.
Did you one more? Did you already share any tutorial about
No,
heat
no, no,
exchanger?
no, no,
Because
no,
I
no,
can't.
no. I will
Yeah.
I will share tomorrow or day after tomorrow.
Okay, right. Then we'll see then. Okay.
Yes, yes, Mr. Fahad.
जी सर, आजकल एक और सॉफ्टवेयर भी इसमें मार्केट में चल रहा है जो कि इन प्रैक्टिस है, जो आपने हीट एक्सचेंजर HEN का डिफाइन किया था उसमें, जिसको वो PDMS कहते हैं. इट्स राइट नाउ इट्स नॉट operational in Pakistan, but it's operational in UAE and other sites पे.
I have heard basically I have heard two software very much demanding for the heat exchanger. One is which is more valuable in the professional history is HTRI, heat exchanger rating and integration. HTRI, heat transfer rating and
Yes, HTRI is more useful. Yes, yes, that's right.
so
Yes.
this
Yes, yes, yes.
HTRI grabbed the 90% market of exchanger design. So Aspen thought that why not we develop our own. So EDR is the one what you call the competitor, uh, which has the competition. I will share one document which I downloaded from internet just yesterday for giving you lecture, and this document actually demonstrate uh, the very interesting aspect of heat exchanger, and then both software configurations. Heat exchanger TEM, it first demonstrate what is heat exchanger and what is this, and then it will give you the insight of HTRI and inside of the uh, only HTRI, but another presentation which actually compares both. So I will share you my searching today's and yesterday's searching. So hopefully you will have some interesting thing from this.
There is
TJ,
another thing called
uh,
HTFS also. HTFS.
HTFS, I don't find HTFS.
But HTRI, HYSYS is also working on HTFS, so I don't know.
Yeah, yeah. This actually compares the HTRI and EDR. See the logos, and it this presentation actually compares the both approaches. How HTRI is calculating, how that, और दोनों में चीजें सेम है, बट अगर आपने ये प्रेजेंटेशन समझ ली तो आप सारी जो चीजें हैं वो समझ जाएंगे कि HTRI में कैसा है और EDR में कैसा है. जैसे EDR.
Do you have, sir, HTRI already on your PC?
HDR, I have software, but I have not installed. Once I installed and could work with the HDRI as well.
Okay, okay.
Okay, now I'm closing this lecture, and we will inshallah move on in the next lecture.
Thank you so much. Thank you. Thank you.
Okay, Allah Hafiz.